Hi, welcome back to the channel. In today's video, we're going to look at a couple of problems on sequences and series. So let's just get right into it. So the first problem here is asking us to find, so we have a sequence and the problem is asking us to find the nth term and the eighth term of the sequence. Now, let's look at the sequence. Let's take a closer look at the sequence, right? Now, we notice that none of this sequence is neither arithmetic nor geometric, neither arithmetic nor geometric. And those are the two sequence, and those are the two types of sequences that we discussed in the previous video. Okay, so they're both it's neither arithmetic nor geometric. So how do we know this? Because if it was arithmetic, we should have a common difference, right? Which would be 1/4 minus 1, and this should also be equal to the difference between the third term and the second term, but these are not actually equal, so it is not arithmetic. Now, if it was geometric, then the ratio of the second term to the first term should also be equal to the ratio of the third term to the second term, which actually they are not equal. So it's neither arithmetic nor geometric. But then can we still be able to find a relationship between a kind of general pattern of this sequence? Yes, we can identify it. We can quickly notice that the first term can be written as 1 square, which is correct, and the second term can be written as 1/2 square. Third term is 1/3 square. Oh, it seems like we have a winner here. Now, which means that we can easily write this 1 square as 1/1 square. Okay, so this tells us that we could actually deduce that the nth term of this sequence is 1/n square. As we observe that the first term is 1/1 square, the second term is 1/2 square, and so on and so forth. So this would be a reasonable conclusion for the nth term of the sequence. Now we are asked to find the eighth term, which is just going to be 1/8 square, which is 1/64. So that will be the answer to the two problems. Good. Now let's move to question 2. So the question 2 says that there's a geometric sequence. So we know that there's a geometric sequence. Then the first term of this geometric sequence, so let's use B. The first term of this geometric sequence is 7, which is B1. And this is a useful skill to have. Whatever information you're given about that sequence, make sure you write out the things that you know about that sequence. So B1 is given, and also the last term. We don't know what this last term means, so we just call it the nth term, right? And it's 488. And then we know that the sum to the nth term to that last term would be equal to 889. Now, this is how to deduce the information and write them in a very concise way using the terms, using the language of sequences to express the information that you're given in the problem. Okay, now that we have this, the question is to find a common ratio. Remember, I told you in the previous video that usually when you have problems with sequences, you are given all the knowns are enough to find the unknowns, right? Now let's see, how does this thing fit in? For example, the first thing I always do is to write my formulas, right? I know that this formula for the nth term of a geometric sequence is n-1. And I know that Sn is B1 r raised to power n-1 over r minus 1. This tells me these two formulas are enough for me to solve this particular problem. Now let's see, how do we now solve the problem? Okay, now from the first one, there are a couple of ways to do it, but I just want to do this in a very natural way where you don't have to know some kind of tricks to solve the problem. So let's see, Bn is given is 488. So we write whatever we know. B1 is given, which is 7, then r raised to power n-1. This tells us that we can actually find what r raised to power n-1 is. Okay, so if you have a calculator like I do around here, I'm just going to try and see what that gives me. It's not a perfect number anyways. So what I know is So basically, we'll leave this for now. We just write this as what? B1 raised to power r, B1 r raised to power n minus 1 is 488. We know this. Now, let's come back to Sn. We know that what? Sn is what? 889. 889 is equal to what? Now, expand the numerator. You have B1 r raised to power n minus B1 all over r minus 1. Remember, I'm multiplying this with this minus this times this. Okay, that's what I have in the numerator. Now, I know what B1 is, which is fine. All I need to know now is what n is, but I don't know n. Okay, how can I find this? It's actually a tricky situation. All I can do is I can use a simple trick with this B1 r raised to power n. Remember, I said I don't want any type of trick. It happens that you can't really escape it. At the barest minimum, you could use another different way of coming through this particular equation, and then you kind of simplify something that will help you evaluate this. But let's look at both ways. Basically, let's just look at both ways. Now, I know that what B1 r raised to power n, I don't know this, but I can rewrite it in a separate, in a different way, such that I can get this off of that, right? This is the simple trick I was talking about. We know that what B1 r raised to power n minus 1 is 488. We could use this information here. How can we use it? B1 r raised to power n can be written as what? B1 r raised to power n minus 1 times what? R. Yeah, using your knowledge of indices, right? So now this gives us what? B1 r raised to power n minus 1 is just 488, right? Times, then you have your r times r. So this is just a simple trick I was talking about. Now we can continue from here. So 889 would be equal to, instead of B1 r raised to power n, I'll have 488 r, then minus B1, which is 7, all over r minus 1. Then you're not ready to cross multiply. So when you cross multiply, you have 889 times r minus 1, and this is equal to 488 r minus 7. So expand. So again, I will expand this by multiplying 889 through the bracket. I would have this. Okay, good. Now make our subject a formula. So which means I will move this thing here and I'll move this other one to the other side. So let's do that. So that will give us 889r minus 488r, and that will be equal to 889 minus 7. So when I move this to the other side, I will have 889. Okay. So when I move minus 889 to the other side, it becomes plus 889. So now I can simplify this. For 889 minus 488. So what does this give us? We have 1 here, we have 0 here, we have 4 here. So we have 401 r, and this is equal to 889 minus 7. That's just 882. So your r becomes 882 divided by what? 401. And this, frankly, is the final answer to the problem in a very simple way. Now, this is the way I would recommend if you know the trick to solve the problem. But let's say you don't understand the trick, you don't know how to simplify this. Okay, you couldn't see this off the cuff from the problem. So what would you do? Now, the second way is to simply what? Look at this. So we are back to 488 equal to 7 and r n raised to power minus 1, right? So you can find r raised to power n minus 1 as what? 488 divided by what? 7. Okay, you can do this, right? Now remember that you have b1 r raised to power n from this second equation. So what do you need? You need r raised to power n, not r raised to power n minus 1. And you notice that what you can write r raised to power n minus 1 as r raised to power n, because of the minus is that's divided by r using laws of indices, equal to 488 over r over 7. So that means r raised to power n is actually 488 over 7 times r. You can do this. All right. Now that you know this, you can come back to the equation 889 equal to b1 r raised to power n minus b1 over r minus 1. So which gives us B1 is 7. R raised to power n, you just got it. 488R over 7, then minus 7 over R minus 1. So 7 would cancel 7 when you multiply through, and you're back to where we were, which is 488R minus 7 over R minus 1. So this is what you can do. Another trick, another way to, not really a trick, another natural way to look at the problem that will help you complete this particular question. Okay, so that is that. So now let's go to the third problem, which says find the sum of the first 6 terms. So we're looking for S6 in this question 3. Okay, it's the sum of the first 6 terms of the geometric series whose third term, so we know that what third term, so we are using B. The third term is given as what 27, and the 6th term is given as what 8, right? So the third term is given as 27 and the 6th term is given as what 8. We are looking for what S6. Now what you always do is, don't forget, represent the knowns with the formulas that you have. Don't forget this. This is a very useful habit to have when it comes to sequences and series. S6, don't forget, is what B. So I constantly move between A and B. So it's B1 R raised to power n. In this case, n is 6 minus 1 over R minus 1. Now, what is missing in finding S6 is what? You need to know B1. So B1 is missing, and we also need to know R. So these are the 2 unknowns that we need. And hopefully, those 2 unknowns can be gotten from these 2 knowns that we have from B3 and B6. So what you do next is you find the formula for B3, which is B1 R raised to power 3 minus 1, which is B1 R2. And this is equal to 27. Then B6, which is B1 R raised to power 5, and this is given as what 8. Very good. Now, you have 2 equations with 2 unknowns. Now, anytime you are dealing with solving 2 simultaneous equations and you are dealing with geometric sequence, a useful skill to have in simplifying and solving those 2 equations simultaneously would be to divide the higher term with the lower term. So you generally just divide the higher term, which is B6 over what? B3. Do this division, right? Just find the ratio of this. Now, when you do that, that would mean B1 R raised to power 5 over B1 R squared. Now, the reason why you're divided is because you want B1 to cancel out, right? When you divide, you cancel out B1, okay? So this is the reason why that works. So you have 8 over 27. Now, when you do this, B1 will cancel out. What would you have? You have R raised to power 5 minus 2 using indices, right? Because you have division. So that will be R raised to power 5 minus 2. So which means R raised to power 3 equal to 8 over 27. Now, what is R? R is just the cube root of what? 8 over 27. So you take the cube root of both sides to eliminate the power, right? Now, if you use a calculator, this would give you 2 over 3, right? But a simple way to look at this is cube root of what? Notice that what 8 over 27 can be written as what? 2 raised to power 3 over 3 raised to power 3. And therefore, you can actually write this as 2 raised to power 3. Then the cube root becomes, cube root will cancel the cube, okay? And that's how you get 2 over 3. So the common ratio that you were looking for is 2 over 3. Now we need to now use this common ratio to find B1, right? So you can substitute this common ratio in any of the 2 equations that you have, right? So what does that mean? Substitute R into B3. So that will be B1 R squared, don't forget, is equal to 27. So which means B1 times 2 over 3 squared equal to 27. So that's B1 times 4 over 9 equal to 27, which means B1 is 27 times 9 over 4. So you just cross multiply and divide by 4, right? That would give you this. Okay. Now, so now that we have this, so what does that give us? So that's just so this is 3 raised to power 3 times 2 square. So this is 3 raised to the power 5 over 2 square. So what's 3 raised to the power 5? That is 343 over 4. So let me just cross check that. 3 raised to the power 4 is 81. 81 times 3 is, okay, is 243, right? 243 over 4. That is B1. Now you are ready to now solve S6. So let's go back to finding S6. Okay, S6 is basically B1 243 over 4 times R. What is R? 2 over 3 raised to the power 6 minus 1 all over 2 over 3 minus 1. Well, this is going to be a little bit of a long computation. So you have 2 over 3 over 4, but it can be done. You can just basically use your calculator to evaluate this. 2 over 3 minus 1 is minus 1 over 3. Okay. So so you basically have divide by 1 minus 1 over 3. That will give us times 3 over minus 1. Then 2 over 3 raised to the power 6 minus 1. Okay. So you can just use a calculator to punch the numbers to give you what you need. So I'll just simplify it to one more level, and then you can complete the problem using your calculator. Okay. So you have minus 729 here over 4 times 2 over 3 raised to the power 6 minus 1. So this would give you the answer you are looking. This will give you the answer you are looking for. All right, so that basically gives us the answer to that particular problem. Okay, so this would cap the 3 problems that we have for this particular video. Watch out for the next video, which we are going to use to solve more problems on sequence and series. And if you have any particular problem that you would want to see on this channel, make sure you comment it down below or send it to me through my email. The link is down in the description, and I will see you guys in the next video.